Hello my dear students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in today's session we are going to deal with the motion in a straight line, lecture number 4. So where in lecture number 3, so we have covered the graphs, so especially the position time graph and the velocity time graph. So in detail we analyzed different graphs and we solved some questions as well, and I told you some tricks also. So in today's session we are going to cover the questions based on motion under uniform acceleration, and then we'll also cover the motion under gravity. So this concept mainly will focus today. Okay, chalo. So as usual for the next 1 hour or 1.5 hours, just be with me. So avoid all the disturbances around you guys, and at the end of the lecture it's very important to prepare your own short notes. Okay, so don't dependent on any other like notes, so just prepare your own short notes. Okay, that will be very useful in the future whenever you are going to write the exam. So at that time, so you'll understand the importance of the short notes. Chalo. So before going to the today's topic, so in the last session, so the last part, so in the last session, so in the last part, so where I started, if a body covers, this is from last class. So we solved one standard result, right? 2 standard results in the last class at the end. So first one, see, if the body starts from rest and it accelerates for some time with an acceleration alpha, sometime t1, and then so from this point it starts decelerating and then it comes to rest. So it decelerates at an beta, right? So acceleration is equals to minus beta. So for a time t2. So then we solved what is the ratio of t1 to t2. So which is equals to, so which is beta by alpha. So this is a standard result from the last class we learned, right? So now, so and similar same concept we have also seen if the body starts from rest and then accelerates for some time, and then so from this point it decelerates and then it comes to rest. Okay, so then the total time elapsed, let it be t, and then so in the time t1 it accelerates for a is equals to alpha. So from here it decelerates, so decelerates at the rate beta, so acceleration is equals to minus beta, and then here its velocity will become maximum. So here its velocity will become maximum, right? So what is that maximum velocity that we have derived in the last class? So alpha beta t by alpha plus beta, alpha beta t by alpha plus beta. So this is a maximum velocity. So now my question is, so find how much distance the body has traveled. Find the distance traveled by the body in this situation. That's my question. So first to find the distance, what I am doing is, let's draw the graph for this. Let's draw the velocity time graph. So for this situation, if I draw the velocity time graph, again let me draw the diagram. So here like this, so body initially starts from rest, and then here its velocity will become maximum, and then here it accelerates at the rate alpha, here it decelerates at the rate beta, and then it comes to rest. So this situation, just draw in the graph. So the velocity time graph I am drawing. So this is the velocity and this is the time graph. So see here. So first its initial velocity is 0. So then its velocity increasing and becoming maximum. Its velocity is increasing, here it's becoming maximum. So from there its velocity getting decreases and then becoming 0. From there its velocity gets decreases with respect to time, and then it becomes 0. Then it becomes 0. So just analyze the situation and draw the graph for that. So the simple thing is just analyze the situation and draw the graph for that. So see here, it started from rest. So then it accelerates and its velocity become maximum. So at this point the velocity will be the maximum. So this is a Vmax, right? So I can write here better. So here let's write this is a Vmax, and then this is the total time taken by the body from here to here. So again finally it comes to rest, right? So this is the graph of this situation. Now I need what is the distance traveled. Find the distance traveled. So how do you find the distance traveled? The simple logic, you know that the area under VT curve will give the area under VT curve will give the distance traveled by the body. So I can write here area under VT curve. Area under VT curve. So if you see the curve, so how is it? So it's in the triangle shape. So simply the area of this triangle shall I find? So what's the area? Half into base into height, right? So half into, so in the base we have taken time. So the total time from here to here, how much time it has taken? So the t time into, so how much height? So what is the maximum height? So the maximum height is nothing but Vmax. So the maximum height is nothing but Vmax. So then half into base time into, so we know the Vmax formula already. The Vmax we already derived it in the last class. Alpha beta t by alpha plus beta. Alpha beta t by alpha plus beta. This we already derived in the last class. So therefore the total distance traveled, therefore the distance traveled will be equals to, so I can write, so alpha beta by 2 times alpha plus beta into t square. Alpha beta t into t square by, so 2 into alpha plus beta. So this result everyone understood? So these are the 3 standard results that you should remember. So if the question asked, if they ask the question, they may ask based on the graph, they may ask what is the distance traveled by the body, or they may ask what is the maximum velocity, and then so what is the ratio of the times. So from this situation they can ask any question. Hope it is clear now. Done? Chal. So now let's move to the next concept. So just note this point. So now let's go for the motion under gravity. So whenever the body is dropped, so freely falling body, or the body is dropped from some height, or the body is dropped from some height, or the body is released from some height, or the body is released from some height. So for all these situations we say the body is motion under gravity. So and in all these scenarios the initial velocity of the body will be taken as 0. In all these scenarios, so the initial velocity of the body is taken as 0. Freely falling body, dropped body, are released from some height if they say. So these are the hints that you can consider. The initial velocity is given as 0. Okay, chalo. So and you already learnt in the grade 9th. So g we should take it as 9.8 meter per second square for points near the earth's surface. And then so for easier calculations we take sometimes 10. If they don't mention, take it as g is equals to 9.8. So for easier calculations you can take it as 10. And then 1D motion under gravity, motion with constant acceleration g downwards. So this acceleration will be equals to, under motion under gravity questions you can take a is equals to z. A is equals to directly g. Okay, sure. With a constant or uniform acceleration it moves down. So then we already know the kinematic equations. So what are the 3 kinematic equations that we learned under uniform acceleration? V is equals to u plus at, s is equals to ut plus half at square, and then v square minus u square is equals to 2as. V square minus u square is equals to 2as. So these are the 3 kinematic equations which we already learned. So using these 3 equations and then the motion under gravity concept, a is equals to g, we are going to solve the questions. So through questions we'll understand the concept. The concept is, that's it. This is the concept. motion under gravity. But how you solve the different questions is important. So for that, I am going to take at least some 14 questions in today's session based on this topic, so that every topic will be covered. Okay, sure. So, and sign conventions are also very important, guys. Let's go for the sign conventions as well. So the sign conventions, whenever the displacement, for example, see, so you have thrown a body from here, so or else a body is at some height, this is a height, so body is initially here, so then finally it's dropped and fallen on the ground. So then if the initial position, if the final position is below the initial position, this is the initial position, this is the final position. So if the final position is below the initial position, so then displacement we take it as negative. If the final position is below the initial position, if final position is below the initial position, displacement will be taken as negative. So or else, let's suppose if you throw an object upwards and then it reached here, so in this case the displacement will be taken as positive, because initial position is here, final position is here, the final position is above the initial position. Okay, so the S is equals to positive you can take. Understood? So related to displacement. And velocity, whenever you throw the body upwards, for the upwards body, if the body is thrown upward, its velocity is considered as positive. So if the body is moving downwards, its velocity is considered as negative. So these are the standard sign conventions. So using these sign conventions only we are going to solve the questions. And then acceleration is always towards the ground, so that's why we take it as minus g always. A is equals to minus g always. So just follow the sign conventions as I am discussing. So every question you'll get the correct answer only. So clear this part first. So displacement, how you should take? If the final position is above the initial position, displacement positive. If the final position is below the initial position, so then displacement negative. Velocity, when you throw body upwards, velocity positive. When you drop something, or when a body is moving downwards, velocity negative. And acceleration due to gravity, A is equals to minus g always. Okay, chalo. Now, so let's solve the questions. So through questions we'll understand the concepts. So the first question, see here. Pause the video and try it on your own. The simple standard result. A stone of mass m is dropped from a tower of height h. So let's consider a tower of height h first. So consider this is a tower of height h. So there is a stone which is having mass m is dropped. So what does it mean by dropped? So its initial velocity is 0. Its initial velocity is 0. So then, so time taken by it to hit the ground. So how much time does it take to hit the ground? First question I am solving. So what's the given information? U is equals to 0. So the body is dropped from here so that it reaches the ground. Finally it reaches the ground. This is the initial position, this is the final position. So the displacement is equals to, shall I say, minus h. Follow the sign conventions. So why minus h? Tell me. Because the final position is below the initial position, that's why minus h. And A is always equals to minus g. Okay, so then let the time taken by t is equals to t. So now I am using S is equals to ut plus half at square kinematic equation. So from here we can write S. In place of S I am writing minus h. U, initial velocity is 0, so this total term will become 0. So half A is always minus g into t square. So therefore minus h is equals to gt square by 2. Minus gt square by 2, minus minus gets cancelled. From here I can write t square is equals to 2 into h. Send this g also to this side, 2h by g. So then from here t is equals to root over 2h by g, root over 2h by g. So this is a time taken by a freely falling body to reach the ground. So already you learnt it in the grade 9th itself, right? So this is the first one. So now let's do the second one. What's the second one? So with what velocity, velocity with which it hits the ground, velocity with which it hits the ground. So for that again I am taking the initial velocity is 0. So let the final velocity with which it hits the ground, let it be, so the v velocity v. So now just before hitting the ground, its velocity v. So now, and then what they said, let me use the kinematic equation, v square minus u square is equals to 2as. Okay, so now the distance s is equals to how much distance it's traveling, minus h, right? So v square, we have to find that, u 0, and then 2 into a is always minus g, yes, it is minus h. So then v square is equals to minus into minus plus, so which is 2gh. So from here v is equals to root over 2gh. This is also the standard result. So now two standard results which you have to remember is, whenever you drop a body from some height, so what is the time taken by the body to reach the ground? So which is root over 2h by g, root over 2h by g. And then so v is equals to root 2gh. So with what final velocity it hits the ground? So v is equals to root 2gh. So now here one thing that you have to understand. So the time taken by a freely falling body, the time taken by a freely falling body to reach the ground, is independent of the mass of the body, is independent of mass of the body. It is independent of mass of the body. So when neglecting the air resistance, so we have to neglect air resistance. Understand this statement properly, guys. Understand this statement properly. See here. So the time taken formula, what's that? We have got root over 2h by g. Root over 2h by g. So it just depends on how much height, from how much height you are dropping a body. Depending on that, the time will vary. If you are dropping from some 10 meters, so the time will be some you get. So if you are dropping from some more height, 20 meters, so then the time will be something. But it does not depend on the mass of the body. If you drop a 10 kg stone or 20 kg stone, whatever, okay, so the time taken from some, like from some 10 meters, let's suppose you are dropping 1 kg body and some 2 kg body, so they both will take the same time. So when you neglect the air resistance, okay, so but if air resistance is considered, if air resistance is considered, then time taken will be inversely proportional to the mass of the body. The time taken will be inversely proportional to the mass of the body. So which means the heavier mass body will take more time. So if the mass is more, so the time will be less. So the heavier mass will take less time. Heavier mass will take less time. If the mass is more, so time will be less. So if the mass is less, time will be more. Yes or no? So the heavier mass one will take the less time. So the lesser mass one will take the more time. So if the air resistance is considered. Understood this part? Chalo. So this is also important. Next, let's move further. So let's take one question here. So pause the video and try it on your own, guys. So what's the question says? Two bodies A, which is of mass 1 kg, and B of mass 3 kg, are dropped from height 16 meters and 25 meters respectively. So 16 meters and 25 meters. So the first body, let's suppose this is dropped from 16 meters. And the second body, let's suppose it is dropped from 25 meters. So this is from 16 meters. So then this is dropped from 25 meters. 16 meters and this is dropped from 25. Dropped means this initial velocity 0 and its initial velocity also 0. So now, so the ratio of the time taken by them to reach the ground, simply let the time taken by the first body to reach the ground is T1. Let the time taken by the second body to reach the ground is T2. So how do you find the T1? So T1 is equals to root over 2h by g. So which is root over 2, from how much height you are dropping? 16 by g, let's take it as 10. So g, let's take it as 10. So from here, so we get, so which is root 32, or else take the 16 out. So 4 into root 2 by 10. So let it be. So then what's the time taken by the second body? So which is equals to root over 2h by g again. So which is root over 2 into height. So from how much height? 25 by g 10. So 25, take it out. So which is 5 root over 2 by 10. So this is the time taken by the first body and this is the time taken by the second body. So they are asking the ratio. So therefore T1 by T2. So T1 is what? 4 into root over 2 by 10. And then the second one 5 into root over 2 by 10. So from here root over 2 by 10, root over 2 by 10 cancel. The ratio of T1 to T2, so which will be equals to 4 by 5. So the ratio of T1 to T2 which is equals to 4 by 5. Clear? So it is independent of the mass of the body. So whether it's 1 kg or 3 kg, that doesn't matter. It just depends on the height. Okay. Sure. So let's move further. So the empty slide has come here. So let's delete that. Chalo. So let's go for the question number 3. So what's the question says here? A boy standing at the top of a tower. So let's suppose this is a, So let's suppose this is a tower. So now a boy is standing. So let's suppose Chintu is standing here. So the tower height is 20 meters total height. So then drops a stone. So Chintu is dropping a stone, right? Assuming g is equals to 10 meter per second square. So the velocity with which it hits the ground. So we know that the standard result v is equals to root 2gh, right? So v is equals to root over g value, take it as 10 into height, so 20. So which is nothing but v is equals to 200 into 2. So square root of 400, which is equals to 20 meter per second. So direct question. V is equals to 20 meter per second. Option A is the correct one. Clear, everyone? Chal. So let's move further. So a body is released from the top of a tower of height h. So it takes t seconds to reach the ground. So where will be the ball after t by 2 seconds? So interesting question. So understand the question properly. A body is released from the top of a tower height h. So let's consider first, so the solution. See here. So let's consider this is a top of a tower. Let's consider the height h. So then it takes t seconds to reach the ground. Yes or no? So a body is released from the top of a tower. So from here a stone is released, let's suppose. So then it's take time t seconds. Let's consider time t seconds to reach the ground. So in this scenario we know that the time taken will be root over 2h by g, because they said the body is released. So released means it is moving under motion under gravity, right? So then, so shall I write here t square is equals to 2h by g. I am squaring on both the sides. So t square is equals to 2h by g. So let it be equation number 1. So now what they are saying, see here. So it takes t seconds to reach the ground. Fine. So where will be the ball after t by 2 seconds? Where will be the ball after t by 2 seconds? Where will be the ball after t by 2 seconds? Let's consider this is a height h. So now from t by 2 seconds, let's suppose in t by 2 seconds, this is the time taken t by 2 seconds. Let's suppose the body has reached till here. So as it is released from the top, so its initial velocity is 0. So its initial velocity is 0. The time taken t is equals to t by 2 seconds. And then, so the distance traveled we have to find. So how much distance is it traveling? So we have to find. So then what else they gave? That's it. So now let me use the equation s is equals to ut plus half at square. So you know that as it is moving under motion under gravity, so a is equals to minus g. So this term will become 0 ut. So s is equals to half. So a is minus g. So then t square t square, right? So from here, so I can take this s as minus because this is the initial position. However, the final position will be below the initial position. I can consider it as minus. So then minus s is equals to minus half gt square, right? So then cancel minus minus, s is equals to the distance traveled by it in t by 2 seconds will be equals to, so in place of t, what you do is t by 2. So let's write in place of t, let's write t by 2 whole square. So here also t by 2 whole square, right? So then, so this is going to be half g t square by 4, half g t square by 4. So now what I am doing is half g by 4, half g by 4. In place of t square, I am writing 2h by g. In place of g square, t square, I am writing 2h by g. Fine. So now see here. So g cancel. So 2 cancel. So therefore s is equals to, here h by 4 remained. S is equals to h by 4. So that means in t by 2 seconds, what does that mean? S is equals to h by 4. In t by 2 seconds, the body has covered h by 4 distance from the top. From the top, this s is from the top because it had taken initial velocity here, time from here. So that's why in t by 2 seconds, the body has traveled h by 4 from the top. Now see the options. So h by 2 from the ground. See, from the ground, how much distance it will be? The total height, we consider it as h, right? So the total height is h. The total height is h. So and this s is equals to, we got h by 4. So obviously, this distance will be equals to 3h by 4. Obviously, this distance will be equals to 3h by 4. This is h by 4 and this will be 3h by 4. Yes or no? So therefore, I can write, so the body covers, it will be after t by 2 seconds, the body will be at a height h by 4 from the ground, no. H by 2 from the ground, no. It depends on the mass and volume, no. So at 3h by 4 from the ground. At 3h by 4 from the ground. Okay, na? So this option is also important. Just as you got h by 4, so just don't blindly put h by 4 from the ground. H by 4 not from the ground, it's from the top. Clear? Chalo. So now next. So let's go for the next question. So a stone falls freely under gravity. It covers the distances h1, h2, h3 in the first 5 seconds, in the next 5 seconds, and in the next 5 seconds respectively. So the relation between h1, h2 and h3 is, see here. So first, let's suppose this is a stone is falling from some height. Okay, na? So in the first 5 seconds, it covers h1 distance in the first 5 seconds. So in the next 5 seconds, it covers some h2 distance. So in the next 5 seconds, it covers some h2 distance. Okay. So and then in the next 5 seconds, this is 5 seconds. So in the next 5 seconds, it covers h3 distance. That's what they are saying. A stone falls freely. A stone falls freely. So that means here its initial velocity is 0. Now, so the relation between h1, h2, h3. So what I am going to do is, so 3 different equations I am going to take. For first, let's consider, so this one, let it be 1, let it be 2, so let it be the third journey. Okay, so in the first one, what I am doing is, so consider for h1, where u is equals to 0, and we know a is equals to minus g. So the distance traveled s is equals to, initial position is here, final position is here. So till in the first 5 seconds. So let's consider it as minus h1 I am taking. Okay. So then the time taken t is equals to 5 seconds. So then let me write the equation s is equals to ut plus half at square. S is equals to ut plus half at square. So listen carefully. So s is equals to minus h1. So however the initial velocity is 0, this term will become 0. Half a minus g t, so 5 square, so which will be minus h1 is equals to, so minus half g into 25. So right, so 5 square 25, so minus minus cancel. So then the h1 is equals to 25g by 2. 25g by 2. So let it be aside. So let's keep aside. So now, so I need same equation for the H2. So but for the H2, we don't know what is the velocity here. To calculate H2, we don't know what is the velocity here, right? We don't know that. And then, so for to calculate H2, what I am going to do is, let's consider in the total first 10 seconds, the body covers a distance of H1 plus H2. Because I know the initial velocity. So in first 10 seconds means H1 plus H2 distance it covers. So let's write. So the second case, the second one, where so the distance covered will be equals to minus of H1 plus H2. Why minus? Because the initial position is above the final position. That's why minus, right? So then, so how much time it is taking for this distance? So it's taking 5 plus 5. 5 plus 5, 10 seconds. And then we know that A is equals to minus G, U is equals to 0. So from here, let's write the same equation, ut plus half at square. So in place of S, so let me write minus of H1 plus H2, which is equals to, this term will become 0, half A is minus G into T, so which is 10. For the total H1 plus H2 journey, the time is 10. So then here I can write minus cancel. So therefore H1 plus H2 is equals to, so this is going to be 100. So I can write 100 G by 2. So let it be. So this is the first one, second one. So let it be equation number 2. So now similarly I need it for the H3, the equation for H3 also I need. Or else what you do is simply, don't consider this one. So let's write the H1 plus H2 is equals to 100 G by 2. So now what I am doing is, we already know the H1. What is H1? 25 G by 2. So then H1, in place of H1, I am writing 25 G by 2 is plus H2 is equals to 100 G by 2. So then, which is going to be H2 is equals to 100 G by 2 minus 25 G by 2. So as the denominators are same, so we can directly subtract the numerator terms. So 100 minus 25, which is 75 G by 2. So this is a H2. So we got H2 relation, H2 also. So similarly, can we find for H3? Can we find for H3? So because we don't know what is the initial velocity here, so simply I am considering this whole distance. I am considering this whole distance. Okay. So the initial velocity u is equals to 0. So for the third situation, the initial velocity u is 0. Or else let's do it in the next page. So let's write. So for the third scenario, the distance covered will be equals to minus of H1 plus H2 plus H3 total distance. So what's the total time for all three distances? So 15 seconds, 5 plus 5 plus 5. So 15 seconds. And then we know that A is equals to minus G, U is equals to 0. So then again use the same equation, S is equals to UT plus half AT square. So from here I am writing in place of S minus of H1 plus H2 plus H3. So then this term is however 0, half A is minus G into T. So total 15 whole square, right? So then here I can write minus cancel. So H1 plus H2 plus H3 is equals to half. So this is 225. So 225 G by 2. So now I need only H3. We need only H3. So now can we write the H1 plus H2 plus H3? So already I wrote. So simply, so the H3 is equals to, so 225 G by 2 minus H1 plus H2. So already we got what is H1 plus H2. H1 plus H2 is 100 G by 2. So therefore this is going to be H3 is equals to, so 225 G by 2, so minus 100 G by 2. 100 G by 2. So which is nothing but, so 225 minus 100, which is 125 G by 2. So this is a H3 value. This is a H3. So now we got all three. So we need the relation between them now. So write all the three distances at one place. So h1 I got 25 g by 2. h1 we got 25 g by 2, and then h2 we got 100 g by 2, right? I guess 75 g by 2, sorry, 75 g by 2, and then h3 we got 125 g by 2, right? So from here, so let's consider this as x. So if h1 is equals to x, so h2 will become 3 times x, because 3 into 25g is 75g. So h2 will become 3x, and then h3 will be equals to, so this is 5 times, so 5 times the x. So therefore the ratio is 1:3:5. h1 is to h2 is to h3 will be equals to 1:3:5. So actually this is going to be the standard result from the Galileo's law, so which we will see it in the next session. So the Galileo law of odd numbers. So there you can directly remember this part. Okay, so now check the option, check the answer. So this is the lengthy procedure actually. So now see the options. h1 is equals to 2h2 is equals to 3h3. No, h1 is equals to h2 by 3 is equals to h3 by 5. This is correct. They are in the ratio of 1:3:5. So h2 is equals to 3h2. No, so all three are not equal. Option B is the correct one. Clear? Understood everyone? Chal. So this is the procedure that you should follow. Okay, next let's take one more interesting question here. So what's the question says? The water drops fall at regular intervals from a tap 5 meters above the ground. So now the third drop is leaving the tap at an instant when the first drop touches the ground. How far above the ground is the second drop at that instant? Okay, so don't afraid just by looking at the question. So just understand the statements one by one. So consider this is a water tap. Okay, so the water drops fall at regular intervals. So what does it mean? So the regular intervals means, so they are taking the same time. So like first drop is releasing, after some time the second drop is releasing. So after the same time the third drop is releasing. So that's what the regular intervals. Okay, let's suppose first drop is releasing now. So after 2 seconds the second drop is releasing. So now after 2 seconds third drop will release. Okay, so that's, so now they said, so this tap is 5 meters above from the ground. So consider this is a ground. So let's take a bit here. So then this is a ground. So what is this distance they gave? This distance is 5 meters. So water tap is 5 meters above the ground. So the third drop is leaving the tap. So this is the third drop which is leaving the tap at an instant when the first drop touches the ground. So the first drop is about to touch the ground. So the third drop is releasing. So this is the third drop, right? And then obviously the second drop will be somewhere in the middle. This is the second drop, and this is the first drop. First drop is about to touch the ground, and at that time, so the third drop is releasing from the tap. So clear now? So how far above the second drop at that instant? So we have to find how much height this is. So this height we have to find. So just first water drops fall. So shall I say the initial velocity of each drop is 0? The initial velocity of each drop is 0. So I am considering the first drop. Consider the first drop. So the first drop to second drop. So let's say the time taken t is equals to x. Let's take from here to here t is equals to x. Obviously between these two also the time taken will be x, because they are falling at the regular intervals, right? So this is releasing. So before x seconds this was released already. Before one more x seconds this was released, because the regular intervals, right? So the total time taken by the first drop to reach the ground will be 2x seconds. Shall I say the first drop initial velocity 0, it's taking the time how much? 2x. The time it's taking 2x. And how much distance it is traveling from tap? It is reaching the ground. It is about to reach the ground, touches the ground, first drop touches the ground. So which means from tap to ground, the distance is 5 meters. So therefore, S is equals to minus 5 meters. Why minus 5, sir? Because the final position is below the initial position. Yes or no? Now, S is equals to minus 5 we got. So simply, let me use the kinematic equation. S is equals to ut plus half at square. So from here, the distance which is minus 5. So however, this term will become 0 because the initial velocity is 0. So half. So let's consider A as 10. So they already mentioned. So A is minus 10. So then T. So what is T? T is 2x whole square. Right? So from here, let's cancel minus and minus. So send this 10 to this side. So this is 10. 5 into 210, which is equals to 10 into, this is going to be 4x square. This is going to be 4x square. Yes. So 10 cancel. So then x square is equals to 1 by 4. From there, x equals to 1 by 2 we got. So what is x? The time taken. So the from here to here, the time is 1 by 2 seconds, and from here to here, the time is 1 by 2 seconds. So now what we actually need? So how much height the second drop is from the ground? So how far above the ground is the second drop at that instant? So the second drop also, now let's consider the second drop. Understand properly. Now consider the second drop. So from ground I can't calculate. Why? I don't know what is the initial velocity from the ground. But from the top I can calculate. Why? So the initial velocity of the second drop, as it is dropped, every drop is just freely falling. So that's why u is 0. So how much time it is taking? So from here to here, the time taken is equals to x. X is nothing but 1 by 2 seconds. X is 1 by 2 seconds. So now the distance s we have to find, and initial velocity is 0. So a will be taken as minus 10 meter per second square. So simply, so use the equation s is equals to ut plus half at square. So I can say s is the s term is we have to find. So this term will become 0 as initial velocity is 0. Half. So then this is going to be minus. Why? Final position is below the initial position. So that's why minus half. A is minus 10 into, so 1 by 2 whole square. Right? So then minus cancel. So from here, so I can write s is equals to, so 10 by, so here it is 4, 8. So which is nothing but 8 ones are, and then so 8 ones are, so 2, then so let's write 2 table better. So 10 by 8, which is 5 by 4. So 5 by 4 is nothing but 1.25. We already know this. So that means s is equals to 1.25 meters. So from where this 1.25 meters? So this is at a distance of 1.25 meters from the top, from the water tap, not from the ground. But they are asking from the ground. See here, how far above the ground is the second drop at that instant? So how far above the ground? So that means if it is 1.25, so obviously this is going to be 3.75, right? Because the total distance is 5. Understanding? The total distance is 5. So that's why this is going to be 3.75. So obviously 3.75 from the ground. So don't put the option 1.25 directly when you got this, because this is from the top, from the water tap. Concept is clear, right? Chalo. Next. So now the symmetry in motion under gravity in 1D. So what does it mean by symmetry? First of all, when you throw an object like this, so with some initial velocity you are throwing the object. So let's suppose this object has reached some height, and then again from here it is falling. So you know that the velocity will be 0 at the maximum height. Whenever it reaches a maximum point, let's take some bigger. So shallow. So let's suppose you have thrown an object, so with initial velocity u. So then it reached the top where its velocity will become 0. So from here to here, let's suppose it has taken some time t. So with whatever the time that it has taken to reach the top, so the same time it will be taken to reach the ground from the top again. So whatever the time that it has taken to reach the top from the ground, so the same time it will take to reach the bottom from the top again. Okay, so this, if it is the time t, this is also this time t. Now what is this time t? How do you find this time t? So let me consider the journey of this body from here to here. Let's initial velocity is u, so and final velocity is 0, and then we know that acceleration due to gravity minus g, acceleration due to gravity minus g. So and let's consider the time t is equals to t. So now let me use the equation v is equals to u plus at. So we know that from here to here the final velocity is 0 and initial velocity u, a is minus g, so let the time taken t. So from here u is equals to gt, so therefore the time taken t is equals to u by g, the time taken t is equals to u by g. So which is nothing but, so this body is taking the time u by g, so then from here to here also it will take the same time. So this we call it as time of ascent, right? So while going up, how much time does it take? So time of ascent. So and then while coming down, so whatever the time that it takes, so which is time of descent. So the time of ascent will be equals to time of descent here. The time of ascent will be equals to, we call the time of ascent will be equals to time of descent. So this is one thing. So now what does it mean by symmetry in motion under gravity in 1D? So what does it mean by symmetry? Let's suppose I am considering, see here. So in the first second the body has traveled till here, let's suppose. In the second second the body has traveled till here. In the third second the body has traveled till here. In the fourth second the body has traveled till here. So in 5 seconds this is the distance traveled in first second. This is the distance traveled in second second. This is the distance traveled in third second. This is the distance traveled in fourth second. This is the distance traveled in fifth second. So and then here it's going to be sixth. So here it's going to be seventh. And then here it's going to be eighth. So and here it's going to be ninth. So and here it's going to be 10th. So now what does it mean by symmetry means? So whatever the distance that the body covers in the first second, so in the last second also it covers the same distance. So that means the distance covered in the first second will be equals to the distance covered in the 10th second. The distance covered in the first second will be equals to the distance covered in the 10th second. And similarly, the distance covered in the second second will be equals to the distance covered in the 9th second. That's called symmetry is. So the distance covered in the second will be equals to the distance covered in the 9th. So and the distance covered in the 5th second, if I say the distance covered in the 5th second will be equals to the distance covered in the 6th second. So how much distance that it covers in the last second of its upward journey, the same distance it covers in the first second of downward journey. Remember this point. So whatever the distance the body covers in the last seconds of its upward journey, the same distance it covers in the downward journey of first second. Clear? So now, so the distance covered in the 5th will be equals to the distance covered in the 6th. So similarly you can see the distance covered in the 3rd will be equals to 8th, the distance covered in the 4th will be equals to 7th, in the 2nd will be equals to 9th, in the 1st will be equals to 10th. So just I have taken some 5 seconds. So if it is more, so then it will be, you can equate the symmetries. Understanding this part? Clear? Chal. So this concept is important to solve some questions. So let's go for the question here. So the question number 7. See what's the question says here. If a ball is thrown vertically upwards with speed u. So let's suppose this is the ball. So this ball is thrown with what vertically upwards with speed u. So the distance covered during the last t seconds of its ascent. So understand the question properly. So see here. So when the body is thrown, so then it moves to some height. Here the velocity will become 0. Here the velocity will become 0. And then again it comes to the ground, right? So now what they are asking in the question, the distance covered during the last t seconds of its ascent. So that means, let's suppose in the last t seconds, this is the last t seconds. So whatever the distance that it covers in the last second of ascent, the same distance it covers in the first second of its descent. So in the t seconds, how much distance that it covers, the same distance it covers in the descent. So the distance covered in the, I'll write the statement, the distance covered in last second of ascent will be equals to distance covered in first second of its descent, descent, right? So now you can calculate the descent thing, because while descending, so it's here, its velocity, initial velocity is 0, right? So the initial velocity will be 0, a will be equals to minus g. So now what we have to find? So the distance covered. So simply s is equals to ut plus half at square formula you can use. So in the t seconds we required, so that's why, so the distance which is as the final position is below the initial position, so take it as minus s, and then ut, this term is 0 because the initial velocity is 0 here. The total at the top, the velocity will become 0, right? So that will become the initial velocity while coming down, right? So then half a is minus g, so let the time be t seconds itself. So minus minus cancel, so the distance covered will be equals to half gt square. So the distance covered is half gt square. So option D is the correct one, guys. Clear everyone? Chalo, next. So the interesting question, understand the question properly. A man throws balls with the same speed vertically upwards, one after the another, at an interval of 2 seconds. So at a regular interval of 2 seconds. So what should be the speed of the throw so that more than 2 balls are in the sky at any time? More than 2 balls are in the sky at any time. So first understand the concept. So there is a person, so what he is doing is he is holding some balls and then he is throwing them like this. So then, so first ball he has thrown, okay, let's suppose the first ball is traveling like this, and after 2 seconds he has thrown second ball, then again after 2 seconds he has thrown third ball, and again after 2 seconds again he thrown fourth ball. So now what they are asking us is, what should be the speed of the throw? So what should be the initial velocity so that more than 2 balls are in the sky at any time? So more than 2 balls. So first ball is thrown, and then after 2 seconds second ball is thrown, and then after 2 seconds third ball is thrown. More than 2 balls means minimum 3 balls should be in the air. The first thing you should understand is, so minimum 3 balls should be in air. Should be in air, because they said minimum more than 2 balls are in the sky at any time. So what should be the speed? That's what they are asking. So understand, consider first 3 balls. First consider, let's suppose only 3 balls are in the air. So to have 3 balls in the air, what should be the initial velocity? So now 3 balls in the air means, let's suppose first he has thrown the first ball. So the first ball is coming to this hand, let's suppose. So the second ball is here. So and the third ball is just throwing. So in that case, the 3 balls will be in the air. Just imagine, guys. So first ball he has thrown, okay. Second ball he has thrown, that's also in the air. And the third ball he is throwing. So at that time, the 3 balls will be in the air. So when he is throwing the third ball, the first ball is about to reach the second hand. Yes or no? So the third ball will reach the ground or second hand. So when he throws the first ball, when he throws the third ball, right? So first ball thrown, traveling in the air. After 2 seconds, second ball is thrown, traveling in the air. So and the third ball is just throwing, so that 3 balls will be in the air. So now considering 3 balls, we know that what is the distance traveled by the first ball? What is the time taken by the first ball? Then the time taken by first ball, the time taken by first ball, shall I say 4 seconds? How, sir? Just think logically. The time taken by the first ball, I am saying 4 seconds. Why? Because you have thrown first ball. After 2 seconds, you have thrown second ball. After 2 seconds, you are throwing third ball, so that 3 balls will be in the air. So now first ball covers a time, takes the time to reach the second hand. So 2 seconds between the first ball and second ball, and 2 seconds between the second ball and third ball, right? So total, the first ball is taking the time 4 seconds to reach the ground or second hand. Yes or no? So if it is taking 4 seconds, so shall I say, as per the symmetry, so it's taking 2 seconds to this side and then again 2 seconds to this side. So whatever the time that it takes to time of ascent will be equals to time of descent. Yes or no? So what is the time of ascent formula? We know that T is equals to U by G. Just we are following the concept. T is equals to U by G. What is T? Time of ascent 2 seconds. So U we have to find. G they said take strictly 9.8. So which is equals to, U is equals to 9.8 into 2. So which is nothing but 19.6, right? So 19.6 meter per second. So to have 3 balls in the air, so compulsory the minimum velocity with which you should throw the ball is 19.6 meter per second. Okay, so but they said, so more than 2 balls, more than 2 balls means 3 can be there, 4 also can be there, right? So now if 4 balls to be in the air, 4 balls to be in the air, so then what he should do? Think logically again. So the person is here. So let's suppose Chintu is a person, he is here. So now, so he's throwing the first ball, right? So the imagine like this: first ball thrown, second ball thrown, third ball thrown. So then he is just throwing the fourth ball, so that 4 balls will be in the air. First ball thrown, it's already traveling. Second ball thrown, it's already traveling. So third ball thrown, it's already traveling. So now fourth ball he is throwing, so that 4 balls will be in the air. Now, so while delivering the fourth ball, the first ball will come to the second hand. While delivering the fourth ball, so the first ball is about to come to the second hand. Yes or no? So that 4 balls will be in the ground. So 4 balls will be in the air, right? So now what will be the time taken by the first ball in this scenario? What is the time taken by first ball? Time taken by first ball. Think logically. Think logically. First ball thrown. After 2 seconds, second ball thrown. So and then after 2 seconds, third ball thrown. After 2 seconds, fourth ball thrown. So total between first and second, 2 seconds. Between second and third, 2 seconds. Between third and fourth, 2 seconds. Total the time taken by the first ball will be equals to 6 seconds. I say will be equals to 6 seconds. So while throwing the fourth ball, the first ball is reaching the second hand. So now what is the total time taken by the first ball? So total 6 seconds. So 6 seconds means time of ascent will be equals to 3 seconds and time of descent will be equals to 3 seconds. Yes or no? So in that case again use the formula T is equals to U by G. So then I can write T, we have T 3 seconds, U we have to find, G 9.8. So which will be equals to, U is equals to 9.8 into 3. So which is 27 plus 2.4. So U is equals to 29.4, right, meter per second. So that means to have 4 balls in the air, so the velocity is 29.4 meter per second, and to have 3 balls in the air, 19.6 meter per second. So and to have 5 balls, obviously the velocity should be more, the thrown velocity should be more. So what they are saying, at any speed less than 19.6 meter per second. So no, to minimum 3 balls 19.6. If 4 balls 29.4. If 5 balls to be in the air, so it will be greater than this, obviously. Yes or no? So this option is wrong. Okay, so then only with 19.6, only if it is 19.6, only 3 balls will be in the air. Yes, so this is also wrong. So more than 19.6, yes. So if you throw with more than 19.6, so more than 2 balls can be in the air. So at least 9.8, no. Understood the concept, everyone? Chal. So let's take the next question. The question number 9. So what's the question says here? A body is projected with a velocity u. A body is projected with a velocity u. So then it passes through a certain point above the ground after t1 seconds. So a body is thrown with a velocity u. Fine. So now it passes through the certain point. It passes through the certain point above the ground. So let's suppose this is a certain point. It passes through that after t1 seconds. So how much time from here to here? It's taking t1 seconds. Okay, then. So the time interval after which, so the body passes the same point during the return journey. So again, same point the body should cover. So understand the concept properly. So a body is thrown like this. Then while it's going, it's went up till here and again it's falling. Now, so it's crossing the certain point in time t1 seconds. In t1 seconds, it's crossing certain point. So again it goes up and again it comes down. So to cross the same time, after how much interval it covers it crosses the same point. That means they are asking this time plus this time. So that will be the time they are asking. So shall I say, we know that the total time of ascent, the total till here, the time of ascent is t. So then this time from here to here, how much time it takes? T minus t1. Yes or no? From here to here, the total time taken, let it be t, time of ascent. So that the time taken from here to here, it will be t minus t1, because this is t1 seconds they said. So t minus t1. So if it is t minus t1, we know that as per symmetry, this is also t minus t1. This is also t minus t1. So simply the total after how much times here? The time interval after which the body passes through the same point. So the body passes through the same point will be 2 times t minus t1. 2 times t minus t1. So in place of t, what you can substitute? T is nothing but the time of ascent or time of descent, which is u by g minus t1. So simply logic question, that's it. So 2 times u by g minus t1. Option B is the correct one. Clear? Understood everyone? Chalo. Let's move further. So the question number 10. So what's the question says? So a particle is projected up with initial speed 10 meter per second from the top of a building at time t is equals to 0. So first there is a building. So consider this is a building. From here a particle is projected. From here the particle is projected like this, let's suppose. So then with initial velocity 10 meter per second. With initial velocity 10 meter per second from the top of a building at time t is equals 0. So at time t is equals to 5 seconds, so the particle strikes the ground. So the particle goes up and then it strikes the ground. So how much time total from here to here? T is equals to 5 seconds they are saying. T is equals to 5 seconds. It went up and again it's coming down, right? So then find the height of the building. So we have to find the height of the building. So for its total journey, it's taking time t is equals to 5 seconds. So then its initial velocity is equals to 10 meter per second. Yes or no? And then, so what is the distance that it is covering? This is the initial position. This is the final position. So the displacement is always initial and final position. S is the displacement in S is equals to ut plus half at square. Okay. So the S is equals to minus h, I can say. This is the initial position, this is the final position. So the final position is below the initial position. So that's why the distance between these two is h. So as final position is below the initial position, I am taking minus h. Right? This point is clear? Chalo. So now let me use the equation S is equals to ut plus half at square. So as it is moving under uniform motion, so then we can consider A as minus g. So S is equals to minus h. So u is 10. So time taken 5. So plus half a minus g. So what is minus g? So let's take it as minus 10 into what is t square? What is the t square value? T is 5. So 5 whole square. So from here we get, so minus h is equals to, so 50. So this is minus, so 5 and then this is going to be 5 minus 5 into 5 square, so 5 cube, so 125, right? So then I can get h minus h is equals to, 50 minus 125, so which is minus 75. So minus h is equals to minus 75. So minus minus cancel. So the h is equals to 75 meters. H is equals to 75 meters. So this is a height of the building. So but okay, height of the building is 75 meters. Fine. So then they are also asking us to calculate the maximum height attained by the particle. So what is the maximum height attained by the particle? Maximum height attained by the particle. Maximum height attained by particle. So what will be the maximum height attained by the particle? I can see here. So this initial velocity you know. So when it attains the maximum height, its final velocity will become 0. I am taking here to here journey. From here to here journey I am taking. So let's write. So the time taken. So or else let's do this way. So we know that the t square is equals to 2h by g. T square is equals to 2h by g. So from here t is equals to, so we can write root over 2h by g. So or else 2 into h. How much is a h? 75 by g. So g value 10. So which is t square is equals to, so 150 by 10. So sorry, the maximum height attained, right? They said not time, sorry. So the maximum height attained, so which is h t square is equals to 2h by g, right? So from here 2h by g, 2h is equals to gt square. From here h is equals to gt square by 2. So but we don't know how much time it has taken from here to here. So how do you find that? Let's use v is equals to u plus at. So final velocity is 0, initial velocity 10, acceleration due to gravity minus 10 into t, time t, right? So from here, so 10 is equals to 10t. From here t is equals to 1 second. So if t is 1 second, so substitute that value here. So h will be equals to, so h can't be negative, so that's why take it as g10 into 1 whole square by 2. So s g 1 whole square. So this is 5 meters. So h is equals to 5 meters. So the maximum height attained is going to be 5 meters. So this height, h is not the building height. Building height already we got. So what's the building height? Sorry guys. So what's the building height? So the first to find the height of the building. Height of the building is 75 meters. So this is fine. Okay. So then they are also asking us to calculate the maximum height attained. So from here to here, it's a maximum height attained, right? So what's that maximum height? So which is 5 meters. Clear? Understood? Sure. Next. So let's delete this empty slide. So let's go for the next question. See here. So the question number 11. What's the question says? A particle projected vertically upwards returns to the ground in time t. So which graph represents the correct variation of velocity time graph? So a particle projected vertically upwards. So when the particle is going up, its velocity decreases. When particle is going up, its velocity becomes decreases, and then finally its velocity becomes 0, and then while returning, while going up, its velocity decreases and 0 at maximum, and then again it increases. While coming down, its velocity increases and it will be maximum at the ground, right? So see here, first velocity versus time. So the velocity decreasing, and it's becoming 0 at some point, and again in the negative direction the velocity is increasing. See here. So this is correct one. Velocity first decreasing, here maximum velocity will be there, while going up decreases and becomes 0, and while coming down again it increases, in the negative direction. So here see here, velocity decreasing, becoming 0, and again increasing in the positive direction. No. So velocity increases in the negative direction. This is wrong option. Here velocity increasing while going up. No. So here also velocity increasing while going up. No. So the first one is the correct one. Clear? Sure. So next question. So what will be the ratio of distance covered by a freely falling body? Freely falling body means u is equals to 0 from rest in 4th and 5th seconds. See here, not in 4 seconds and 5 seconds. So the 4th and 5th seconds. So did you remember the distance covered in nth second last class formula? U plus a by 2 into 2n minus 1. U plus a by 2 into 2n minus 1. So now we have to find the distance covered in fourth to the distance covered in fifth. So however, in both the cases, sorry, u is 0. So let me write u into, so let's write a by 2 into, so in the first case 2 into what is fourth second? Fourth second means 2 into 4 minus 1 by, so u plus a by 2 into 2 into fifth second. So 2 into 5 minus 1. So here u is 0. This here also u is 0. So then I can write, so the s fourth to s fifth, which will be equals to, so a by 2 into, so this is 8 minus 1, 7 by, so here also a by 2 into, so 10 minus 1, 9. So a by 2 cancel, so which is going to be 7 by 9. 7 by 9. Clear? So chalo guys, so let's wind up here. So in the next session we'll cover the few questions and then we'll move to the next concept, that is Galileo's law of odd numbers. So that we'll cover. So with that the motion in a straight line will be over. So then we'll start the motion in a plane. Okay. So chalo, we'll meet in the next session. So till then, keep studying. All the very best. Bye guys.